Hello, how are you? My name is Anna Tinmetzel. Welcome back to my channel. I did this solution yesterday on this LeetCode problem set, which is question number 51, N queens, very similar to question number 52, N queens 2. So last night when I did this submission, I didn't do as well as I wanted when it comes to runtime. But when it comes to memory, I was okay. I definitely have some things I want to improve on here. I say that every video, but I truly believe that if you're not hitting 50% on both, you really do have some stuff to work on. And I'm also trying to push these out pretty quickly. So taking a little bit of extra time maybe beforehand and just evaluating the question and how I could have a solution. That's what I should be doing. So I'm going to go through this question, which is, by the way, the solution is in Python, for question number 51. So the n queens puzzle is a problem of placing n queens on an n by n chessboard such that no two queens attack each other. Given an integer n, return all distinct solutions to the n queens puzzle. You may return the answer in any order. Each solution contains a distinct board configuration. Sorry, you guys, my cat is trying to touch me. I don't know if you guys just saw her little hand. N queen's placement where Q and period both indicate a queen and an empty space respectively. So we have here the input of 4, and then we have this output, and there exists two distinct solutions to the 4 queens puzzle as shown here. And Jojo's coming to help. Hi, Jojo. So how I decided to do this, and I also did this for the question after this, 52, I used backtracking to explore this configuration with the queen placement. Okay, all right, okay. This is what happens. If you guys have cats, you know. If you know, you know. And then just checking again for that valid placement of queens and adding valid solutions to the results list. So oh my gosh, you guys, she's having complete zoomies. This was my solution here. So basically, in the beginning, I just checked to see if the queen can be placed at a given position without any conflicts from existing queens. And then I checked for conflicts in the same column with the upper left diagonal and the upper right diagonal. And if there was no conflicts, great. If there was, then we marked those down. And if all this section right here basically is if all the rows are filled, then we add the current board configuration to those results. And then this is where the results were, the board and the solve. So that was my approach to this. And then in the next question, if you guys have seen the video, if you haven't yet, I was able to actually refine this a little bit more and get a slightly better result than this 30-70 situation from last night. But I mean, I definitely want to rework this. I think I think it's a good solution. I think it's a great start, but I'm not entirely sure how to reduce the runtime for this. So that is definitely something I want to try to spearhead a little bit better. But overall, I'm pretty okay with that as a result, and I've already put this code in my GitHub repo, and the link is down in the video description, so you guys can fork and clone. You can make it better, you can make it worse, you can have some fun and learn something new. That's what this is all about. So I will see you guys in the next video. Thank you guys so much for watching. Have a great rest of your day.